So in this lecture we'll see another important modulation, which is differential phase shift keying. As discussed in the previous class, it is one of the variant of phase shift keying, but phase shift keying cannot be used in non-coherent way. So there is a way non-coherent detection is possible through differential phase shift keying. So how does this Dpsk work? Let us see that. So this is block diagram of differential phase shift keying. So this portion will do differential encoding, and this is a PSK. So whole process combination of these two will make differential phase shift keying. Let us see how this scheme work, even though there is no synchronization of the phase both at the transmitter and receiver. That is, if phase information is not known, phase information of the carrier is not known at the transmitter and receiver, still we can detect the bit. Now let us consider this information bit, which is your IK, which is 0, 1, 1, 0 and 1, and the differential bits QK is obtained by XORing of output of delay element and IK, that is in this modulo 2 adder. So initially the reference bit or delay element is in reset state, so that is why these two will yield 0, and again this 2 will yield 1 in the next clock cycle. This 1 1 will yield 0, this 0 0 will yield 0, and 0 1 will yield this 1. And if I go for polar signaling and PSK, then the theta k will become pi pi 0 pi pi 0. Pi corresponds to the phase corresponding to 0 bit, and 1 and 0 corresponds to the phase corresponding to bit 1. Now what if I go for the difference of the phases of the two adjacent bits? What if I'll repeat, what if I go for difference of the phases of two adjacent bits? In that case, my theta k minus 1 would be 0 pi, that is, I'll repeat again, this would be pi minus pi will give 0, pi minus 0 will give pi, 0 minus pi will give pi, though it is minus pi but magnitude wise it is pi. So this will give 0 and this will give pi. And my decision rule, if I choose my decision rule that if detected binary bit decay would be 0 if my this difference is 0, and it would be 1 if my difference is pi, then what I get is this scheme. What I get is this stream at the receiver, and if you compare this with transmitted bits, then this is exactly same. So which means that this scheme is working. Now you may ask, in what way this is non-coherent? Now what we are doing here is we are taking the help of this, that is we are doing the difference of theta k and theta k minus 1. So we have theta k. So suppose the carrier has some unknown phase which is phi. So the phase is theta k plus phi, phase of the kth bit is theta k plus phi, and we are doing a subtraction of this phase with the phase of the previous bit, that is your theta k minus 1 plus, if I assume that this phase which is unknown at the receiver remains same at for at least two bit duration. If this unknown phase remains same for at least two adjacent bit duration for 2 bit duration, in that case I can assume phi here and phi here, and if I take the difference of these two, what I get is your theta k minus 1. So even though this phase is unknown, but still the difference is not taking in, this phase is not coming into consideration in this difference. This is the meaning of having non-coherent detection. even though the phase is unknown to me, I don't know what is phi, even though I don't know, but if I assume that this phi is constant for 2-bit duration, but still I am able to detect at the receiver by taking the difference of the phases as is shown here. So this is how differential phase shift keying works. It is to be noted that PSK is very important and DPSK is also important. PSK is widely used in satellite communication and your D2H transmission, and it is used in different schemes of wireless communication also, and DPSK is also used in different wireless communication schemes. So this is how PSK and this is how PSK scheme work in coherent and non-coherent way. So this is basically important point here is a matter of discussion here is a DPSK, how to generate and how to detect that. So this is a DPSK receiver. To implement that, so what we do is, this is we have to go for phase detection. So this is a phase detector, and then we are comparing, we are using a sampler, taking a sample value and comparing with a threshold in the decision device. So this is the threshold in decision device. In the similar way as we have done previously, we'll get 1 if my sample value is greater than lambda, and if my sample value is less than lambda, I'll get 0 volt. So this is more about, so this is something about DPSK, which is important modulation scheme, non-coherent modulation scheme in communication engineering.